Welcome to this academic lecture on project management fundamentals, with a particular focus on its application in the regulatory affairs and medical device industry. As we begin this exploration, it is crucial to appreciate the foundational role that project management plays in orchestrating complex endeavors, ensuring they are delivered on time, within budget, and to the required quality standards. In the context of medical devices, where regulatory compliance and patient safety are paramount, effective project management becomes not just a tool but a necessity for success. Project management, at its core, is the application of knowledge, skills, tools, and techniques to project activities to meet project requirements. Drawing from established frameworks like the PMBOK Guide by the Project Management Institute, PMI, we understand it as a structured approach encompassing initiation, planning, execution, monitoring, and closure. In regulatory affairs, this discipline ensures that projects align with stringent guidelines from bodies such as the FDA, EMA, and Health Canada, mitigating risks associated with non-compliance that could lead to delays, recalls, or legal repercussions. The relevance of this topic is underscored by industry reports, such as those from McKinsey & Company, which highlight that organizations with mature project management practices complete 89% of projects successfully, compared to only 36% for those without. In medtech, where projects involve intricate processes like design controls and clinical trials, mastering fundamentals can mean the difference between market leadership and obsolescence. Throughout this lecture, we will follow a logical progression, starting with an overview and the importance of project management, then delving into core concepts, specialized tools and techniques for medical device projects, strategies for aligning with business objectives, and extending to advanced topics such as risk management, stakeholder engagement, case studies, challenges, and future trends. We will reference empirical studies and best practices to provide a rigorous academic foundation. To foster engagement, I invite you to reflect on your experiences with projects, perhaps a regulatory submission or device development, and consider how fundamentals could enhance outcomes. As we proceed, we will draw on scholarly sources like the International Journal of Project Management to substantiate our discussions. Let us now move to the overview slide to establish the foundational context. Building on our introduction, this overview elucidates the essence of project management fundamentals in the medical device and regulatory affairs domain. Project management is defined as the systematic process of initiating, planning, executing, monitoring, controlling, and closing projects to achieve specific goals and meet success criteria at a specified time. In the highly regulated medtech industry, it integrates compliance with innovation, ensuring that devices meet safety and efficacy standards while advancing business aims. Key elements include the project lifecycle, which spans from conception to delivery, incorporating phases like feasibility studies, design, testing, and market launch. According to PMI's Pulse of the Profession report, organizations excelling in project management waste 28 times less money due to poor performance. For medical devices, this translates to navigating complex regulations such as FDA's 21 CFR Part 820 or EU MDR, where project delays can cost millions. In regulatory affairs, project management bridges technical requirements with strategic objectives, employing methodologies like waterfall for linear processes or agile for iterative development. Tools such as Gantt charts for scheduling, risk registers for threats, and dashboards for real-time tracking are indispensable. Alignment with business objectives involves prioritizing projects that enhance market position, such as accelerating time to market for competitive edge. Academic literature, including studies from the Journal of Product Innovation Management, emphasizes that effective project management in medtech reduces failure rates by incorporating cross-functional teams and stakeholder inputs early. Factors like resource constraints, regulatory changes, and technological advancements add layers of complexity, necessitating adaptive strategies. Practically, this ensures compliance through structured documentation and audits, while meeting objectives like cost control and quality assurance. Consider a scenario: developing a new implantable device amid evolving EMA guidelines requires robust planning to avoid rework. This overview primes us for deeper dives. As we advance, contemplate applications in your field. How might these fundamentals streamline a submission process? Our discourse will leverage evidence-based insights for comprehensive understanding. The importance of project management in regulatory affairs cannot be overstated, as it forms the backbone for successful medical device development and commercialization. This segment explores its critical value through an academic lens, supported by industry data and scholarly insights. Primarily, it ensures regulatory compliance and patient safety by structuring processes to adhere to standards like ISO 13485 and FDA QSR, preventing violations that could lead to sanctions or harm. Studies from the Regulatory Affairs Professional Society, RAPS, indicate that well-managed projects reduce compliance risks by 40%, safeguarding public health. Additionally, it optimizes resource utilization, allocating budgets, personnel, and time effectively amid constraints. PMI reports highlight that poor management leads to 11.4% of investment waste. In medtech, this means efficient use of R&D funds for innovation without overspending. Facilitating timely market entry is key, as delays erode competitive advantages. Effective planning compresses timelines for submissions and approvals, with data showing managed projects meet deadlines 2.5 times more often. It also enhances cross-functional collaboration, uniting teams from regulatory, quality, and clinical domains, fostering knowledge sharing and reducing silos, as per Harvard Business Review analyses. Finally, it supports strategic alignment, ensuring projects contribute to business goals like revenue growth and market expansion. In summary, project management is indispensable for medtech success. Reflect on cases like delayed device launches due to mismanagement. This prepares us for core concepts. Now, let's dive into our first core concept, the project lifecycle. In the medical device industry, think of this as our primary navigation system. It's a sequential framework that guides a device from its initial spark, the inception, all the way to market release and final completion. Academically, this mirrors the PMI process groups, but with a critical twist: every stage is specifically adapted to meet heavy regulatory demands. Let's walk through how this looks in practice. Initiation: we start by defining our scope and stakeholders. But unlike general tech, we perform a regulatory feasibility check right here. For example, can this concept actually pass MDR requirements? If the answer is no, the project stops before it starts. Planning: this is where we build the roadmap. In medtech, planning isn't just about dates and resources, it's about compliance documentation. The risk management plans we create here become the foundation of our technical files. Execution: this is the doing phase, the actual design and testing. The key word here is traceability. We must be able to prove that every feature of the device correlates back to a specific user need. Monitoring: we use KPIs to stay on track, but we also have to be ready for regulatory feedback loops. If a regulator raises a concern mid-project, this is where we adjust the sails. Closure: we don't just finish. We conduct final audits and capture lessons learned. In this industry, a mistake in one project is a vital data point for the safety of the next. So, why use such a rigid structure? It's because this lifecycle allows us to bake design controls and validation directly into the workflow. The data backs this up, empirical studies show that using these structured life cycles can boost project success rates by 30%. That is a massive margin when millions of dollars and patient lives are on the line. Before we move to scope management, I want to leave you with a thought. Much of what I just described follows a traditional, linear flow. How do you think an agile methodology would modify this for iterative software-based devices? Keep that in mind as we move to our next topic, scope management. Now, let's move into our next vital core concept, scope management. In the medical device world, this is all about defining and controlling exactly what is included in the project to prevent costly overruns. Academically, this is our primary defense against scope creep, which is incredibly common and dangerous in regulated environments. Here is how we handle it effectively. Defining boundaries, we set clear deliverables, such as device specifications that align directly with FDA classifications. Managing changes, we use formal processes to evaluate how any requested change might impact our compliance status and our timelines. Requirements gathering, this isn't just a wish list, it incorporates regulatory needs, user inputs, and core business goals. Using the right tools, we rely on tools like the Work Breakdown Structure, or WBS, to decompose complex tasks, and we use scope statements to formally document our agreements. In medtech, the stakes for getting this wrong are high. Poor scope management leads to expensive redesigns. However, studies indicate that effective management can reduce overall costs by 20%. As we wrap up this section, I want you to ponder a difficult question: how do we handle scope when regulations themselves are evolving mid-project? This challenge leads us directly into our next topic, time management. Let's shift our focus to time management, another pillar of project success. In the medtech sector, time management isn't just about efficiency, it is what ensures our projects meet critical deadlines, which is vital because any delay directly impacts our window for market entry. This concept fundamentally involves carefully sequencing activities and estimating how long each will take. To manage our schedules effectively, we look at several key strategies. Scheduling tools, we use tools like Gantt charts to visualize our entire timeline. It is essential that we bake in specific milestones, particularly our regulatory submission dates. The critical path, we utilize the critical path method to identify the exact sequence of tasks that determines the overall project duration. This allows us to prioritize the activities that cannot afford a delay. Contingency planning, handling delays requires proactive planning. We must have contingencies in place, specifically for the unpredictable nature of regulatory reviews. The data underscores why we prioritize this. Empirical data from the PMI shows that projects with good time management complete on time 83% of the time. Before we move on, I want you to reflect on this. What strategies could we use to actually accelerate these regulatory approvals? Take a moment with that, because it leads us naturally into our next section, cost management. Let's shift our focus to cost management, a fundamental pillar for ensuring profitability in medical device projects. In our field, this isn't just about spending, it's a comprehensive process that encompasses planning, estimating, budgeting, and strictly controlling financial resources. Here is how we break down the financial side of a project. Budgeting, this is where we allocate critical funds specifically for R&D, clinical trials, and regulatory submissions. Cost control, we don't just set a budget and forget it, we actively monitor variances using techniques like variance analysis to catch overruns before they spiral. Earned value management, this is a powerful integration tool. It combines scope, schedule, and cost into a single set of performance metrics so we can see the true health of the project. In medtech, we face a unique challenge, balancing cost with quality. We must ensure we never skimp on safety, adhering strictly to ISO standards even when budgets are tight. The business case for this rigor is clear. Studies reveal that effective cost management can save between 15% and 20% on total project costs. As we move forward, I want you to consider a real-world economic factor. What is the impact of inflation on our long-term, multi-year development projects? That financial pressure leads us directly into our next critical topic, quality management. To wrap up our discussion on methodologies, let's look at the specific tools and techniques required to manage the unique complexities of medical device projects. Because of the heavy regulatory burden we face, we cannot rely on generic management styles. We need specialized approaches to handle this level of intricacy. Here is a breakdown of the essential tools in our toolkit. Risk management matrices. These are vital for identifying potential threats and documenting exactly how we plan to mitigate them before they impact patient safety. Design control documentation. This is what ensures total traceability throughout the project, linking every design decision back to a specific requirement. Verification and validation protocols. These are the formal tests we use to confirm that the device actually meets all its predefined requirements and intended uses. Submission trackers. These specialized tools allow us to monitor the status of our various regulatory filings across different global markets. Cross-functional collaboration tools. We use platforms like Microsoft Project or Jira to keep our diverse teams, from engineering to clinical affairs, synchronized. Academic analyses emphasize that these tools are not optional, they are the bedrock of compliance. Empirically, we see that the formal adoption of these specialized tools improves overall project efficiency by 25%. As we conclude this section, I want you to consider the rise of digital tools and automated compliance software. How is automation changing the way we document safety? This shift leads us directly into our next deep dive, risk management tools. To wrap up our discussion on methodologies, let's look at the specific tools and techniques required to manage the unique complexities of medical device projects. Because of the heavy regulatory burden we face, we cannot rely on generic management styles. We need specialized approaches to handle this level of intricacy. Here is a breakdown of the essential tools in our toolkit. Risk management matrices. These are vital for identifying potential threats and documenting exactly how we plan to mitigate them before they impact patient safety. Design control documentation. This is what ensures total traceability throughout the project, linking every design decision back to a specific requirement. Verification and validation protocols. These are the formal tests we use to confirm that the device actually meets all its predefined requirements and intended uses. Submission trackers. These specialized tools allow us to monitor the status of our various regulatory filings across different global markets. Cross-functional collaboration tools. We use platforms like Microsoft Project or Jira to keep our diverse teams, from engineering to clinical affairs, synchronized. Academic analyses emphasize that these tools are not optional, they are the bedrock of compliance. Empirically, we see that the formal adoption of these specialized tools improves overall project efficiency by 25%. As we conclude this section, I want you to consider the rise of digital tools and automated compliance software. How is automation changing the way we document safety? This shift leads us directly into our next deep dive, risk management tools. Moving into our final specific toolset, let's focus on risk management matrices. These are absolutely essential tools for assessing threats in medtech projects. By using these matrices, we can categorize risks based on two primary factors: their probability of occurring and the severity of their impact. This process follows a clear structure. Identification. We cover all bases by identifying regulatory, technical, and market risks. Assessment. We then quantify these risks to determine our prioritization. Mitigation. Finally, we develop specific response plans to address the most critical threats. A key requirement in our industry is the integration with ISO 14971, which ensures our analysis is truly comprehensive and safe for the end user. The value of this rigor is proven by the data. Studies show that using these matrices can reduce project failures by as much as 35%. As we open this up for discussion, I want you to consider, how would you customize these matrices for different classes of medical devices? This question of customization leads us directly into our next core area, design controls. Moving to our next key area, let's talk about design control documentation. This isn't just paperwork, it is a systematic framework for development that is strictly mandated by global regulations to provide total traceability. Here is how we build that systematic record. Design History File, DHF. We use the DHF to compile every single record of the device's evolution, from initial concept to final design. Change Controls. We implement rigorous change controls to manage any modifications, ensuring that updates don't compromise safety or compliance. Audit Preparation. This documentation is our primary tool for preparing for audits, as it allows us to demonstrate full regulatory compliance to inspectors at any time. The empirical evidence is clear. Having robust documentation significantly speeds up the regulatory approval process. As we wrap up this section, I want you to consider a practical shift in the industry. What are the pros and cons of moving from traditional paper systems to fully digital, cloud-based documentation? Thinking through that transition leads us perfectly into our next topic, V&V protocols. Moving to our next critical tool set, let's talk about verification and validation, V&V, protocols. These protocols are what we use to confirm that a device's performance actually holds up in the real world. To put it simply, verification checks that the device was built correctly against its technical specifications, while validation confirms we built the right device to meet actual user needs. We use several key methodologies to achieve this. Testing methods. This includes everything from rigorous lab testing to full-scale clinical trials. Standards adherence. All of our documentation must strictly adhere to international standards to be accepted for regulatory submissions. Managing challenges. Our biggest hurdle here is often balancing the extreme rigor required for these tests with our project timelines. The data shows why we invest so much effort here. Robust V&V reduces post-market issues by an impressive 40%. Before we move on, I want you to ponder, what role do human factors play in the validation process? This question of how people actually interact with the device leads us directly into our next tool, submission trackers. Finally, let's wrap up our look at specialized tools by discussing regulatory submission trackers. These trackers are essential for managing the incredibly complex filings required for global market access. They act as a centralized hub to monitor critical deadlines and the real-time status of various applications. Here is how these trackers keep a project on the path to approval. Document compilation. Trackers help ensure every required piece of documentation is present and accounted for, ensuring total completeness before submission. Interaction logs. They provide a formal way to track all communications and interactions with regulatory agencies, which is vital for maintaining a clear history. Revision management. Since submissions are rarely static, update mechanisms within these tools allow us to handle complex revisions efficiently. The effectiveness of this approach is well documented. Studies show that using dedicated trackers significantly improves overall submission success rates. As we move toward our final conclusions, I want you to reflect on this. How can we better integrate these specialized trackers directly with our main project management software to create a single source of truth? That question of organizational synergy leads us to our final discussion, aligning with business objectives. Moving to our final core strategic concept, let's discuss aligning with business objectives. This is where we ensure that all our rigorous regulatory efforts actually support the commercial success of the product. It requires a deep understanding of the specific markets we are entering and the overarching business strategies of the organization. Here is how we achieve that critical alignment. Balancing compliance and speed, we must find the sweet spot between meeting every regulatory requirement and maintaining a competitive time to market. Stakeholder communication. Effective communication acts as the bridge between technical teams and business stakeholders, ensuring everyone is moving toward the same goal. Driving ROI. The ultimate goal is financial health. Empirical data shows that projects properly aligned with business objectives yield a 20% higher ROI. As we conclude this discussion, I want you to consider, what specific metrics should we use to measure this alignment? Thinking about how we quantify success here will lead us naturally into our next section, understanding market needs. To wrap up our strategic overview, let's discuss the final piece of the puzzle, understanding market needs. This core concept is what ensures our projects aren't just compliant, but actually align with real-world demand. By using market research to identify specific opportunities, we can ensure our technical efforts translate into a product that doctors and patients actually want. Here is how we ensure our project remains relevant. Competitive analysis. We use benchmarking to see how our device stands against the current market leaders and to identify gaps we can fill. User requirements. We focus on these to ensure the device is relevant to the end user's daily workflow. Trend forecasting. This allows us to anticipate changes in technology or healthcare policy before they happen, keeping us ahead of the curve. The data is quite compelling here. Studies consistently show that market-aligned projects have significantly higher success rates than those developed in a vacuum. As we finish today's session, I want to leave you with a final reflection. How have post-COVID shifts in healthcare delivery changed what users actually value in a medical device? Understanding those shifts is exactly how we navigate the ever-changing competitive landscapes. Now let's look at how we navigate competitive landscapes. This process is critical for positioning our projects for maximum advantage by identifying exactly where we stand in the market. We often start this with a SWOT analysis to pinpoint our specific strengths and opportunities while remaining clear-eyed about the threats and weaknesses we face. Here is how we maintain a competitive edge. Benchmarking. We use this to measure our project's performance directly against the industry's best, ensuring we aren't just meeting standards but leading them. Differentiation. We focus on developing unique features that solve specific user problems better than any other device currently available. Intellectual property. We prioritize IP to protect our innovations, creating a barrier to entry that secures our market position. The data heavily supports this proactive stance. Studies show that high levels of competitive awareness can directly boost a product's market share. As we close this section, I'll leave you with this to ponder. In an era of rapid globalization, how do we protect our competitive advantage when facing international rivals with different cost structures? That question of high-level strategy leads us directly into our next discussion, organizational goals. Let's explore our last core strategic pillar, organizational goals. Linking our projects directly to these goals is what ensures long-term relevance and sustainability. We use portfolio management as our primary filter to select the projects that best serve the company's vision. Here is how we integrate project work with the bigger picture. Resource prioritization. We use this to focus our team's efforts on the highest impact initiatives, ensuring we aren't spreading our talent too thin. Tracking contributions. We establish specific metrics to track how each project contributes to the organization's overall health and growth. Proven growth. Real-world cases show that companies that maintain this tight alignment see significantly more consistent growth and market stability. As we conclude this lecture series, I want to leave you with a critical reflection. What are the hidden risks of misalignment between a technical team and the executive board? Recognizing those risks is the first step in successfully balancing requirements across the entire organization. We now go over the fundamental challenge of balancing requirements. In our industry, we are constantly navigating the tension between strict regulatory mandates and pressing business needs. This often manifests as a direct conflict between aggressive time-to-market pressures and the need for exhaustive, thorough reviews to ensure patient safety. Here is how we manage this delicate balance. Efficiency amid constraints. We must find ways to maintain high performance even when facing significant resource constraints, which demands a high level of operational efficiency. Cost-effective compliance. Meeting our financial targets requires us to develop compliance strategies that are effective without being prohibitively expensive. Decision-making frameworks. We use a rigorous risk-benefit analysis to guide our most difficult decisions, ensuring that every trade-off is justified by the final outcome. The data confirms that this effort pays off. Empirical evidence shows that these balanced approaches consistently optimize overall project outcomes. As we wrap up, I want to leave you with a final thought for the future. Can we truly implement agile methodologies in such a heavily regulated environment without compromising these standards? Exploring that possibility is the key to our next discussion on communication strategies. To wrap up our core principles, let's discuss effective communication, the vital link that ensures total project alignment. In the medical device industry, communication acts as the essential bridge between technical regulatory requirements and broader business perspectives. Here is how we maintain that flow of information. Stakeholder engagement. We prioritize active engagement with all parties to build the necessary buy-in for complex project decisions. Consistent reporting. We use structured reporting to keep all stakeholders informed of progress, risks, and regulatory milestones. Conflict resolution. We implement formal resolution strategies to address disagreements quickly, ensuring they don't stall our clinical or technical progress. The impact of this cannot be overstated. Empirical data indicates that projects with high-quality communication strategies improve their overall success rates by 50%. As we move toward our final conclusion, I want you to reflect on this. What specific digital tools could we use to streamline this communication across global, multidisciplinary teams? Thinking about those tools is the final step in mastering the complex world of medical device project management. In conclusion, we have navigated the fundamental pillars of project management, specialized tools, and strategic alignment within the medtech landscape. The core takeaway from this lecture is clear. Structured approaches are not just bureaucratic requirements, they are what ensure both regulatory compliance and commercial success in this high-stakes field. We've seen how every phase, from the initial project lifecycle to the final communication strategy, must be executed with precision to protect patient safety and drive innovation.